Right, hello. Coordinate geometry in the last of the ASK topics for Year 10. So it's quite quick, just a couple of things in this really. Equations of circles is one. Now, this circle has equation x squared plus y squared equals 5 squared. Nice. Look at what they've done. They've used Pythagoras. We know that this length squared plus this length squared equals this length squared. So no matter where I go in this circle, okay, no matter what right angle triangle I drew, so random right angle triangle, if I were to draw a right angle triangle in this circle, then I know that that length there, x squared, plus this length here, y squared, will equal 5 squared, which is 25, no matter where I am around the circle, which is how the end point here creates a circle. So the general equation of a circle is this. X squared plus y squared is r squared. So say if we wanted a circle of radius 7, then that would just be 7 squared, which is 49. Now this is only for circles with the centre at the origin. So circles that the centre is there. Now, obviously circles can appear and exist away from the origin. So the general form when it's away from the origin is this. I did do it wrong on the sheet. So ignore these squares here. So it's x minus a all squared plus y minus b all squared is r squared. Now, r is the radius and the centre is AB. Notice that you've got these minuses here, so you have to be careful. So a circle with centre 3, 4 and radius 6. Well, we just put 3 and 4 into here. So it would be x minus 3 all squared plus y minus 4 all squared equals 6 squared. Then you would simplify the 6 squared to get 36. To draw it, you know it has centre 3, 4, so you would do that along here. So where's my axes? It's quite difficult doing this and filming. So 3, 4, so 1, 2, 3 on the x-axis, and 4 on the y, 2, 3, 4 is there. So 3, 4, I'm going to have to turn away. Right, so the centre is there, and we know the radius is 6. So what you would do is you would go 6 up, 6 across, 6 here, 6 here, or you just set your compass to 6 and use that. It's good to have these points in, so 4, so it's going to come around at the top there, so that's 3 along, so it's going to come in, 9 at the side there, and this is 4 up, so a radius of 6 is going to come 6 down, which is 2 below the axes there, and it's 3 along, radius of 6, so we need 3 more this side, which is about there. So drawing this, hang on a sec, as if by magic. Oh, this is really bad, freehand. Okay, there we go. That's actually not too bad. So that is the circle of the equation x minus 3 squared plus y minus 4 squared equals 6 squared. So it's definitely worth looking at my maths on this because it has a really good visual with this as well. Okay, tangents. Now tangents are linked. They often have tangents with circles, and you're drawing a tangent on a circle. Remember the when we had that rule for a circle and a radii, and it's at 90 degrees as a tangent for circle theorems. Okay, so tangents are lines that touch curve at one point. And that's all they do, they just touch the curve at one point. We can use them on graphs as well as circles, and their key use is to find the gradient of curves. So if we wanted to find the gradient of this curve at x equals 3, all we would do is get a ruler and find x equals 3, and we would just get the ruler and just draw a line so it's just touching the curve at x equals 3. I've already done that because it's really hard to do this on film. So then we've got a straight line, and to get the gradient of a straight line we find the change in y over the change in x. And the change in y is going from 1 up to 4. So the change in y is 5. And the change in x is going along from 2 to 3. So this bit of line goes along 1 and up 5. So 5 divided by 1 is just 5. So we've now calculated the gradient at that point. Okay? Now gradients actually represent a rate of change. So what you're doing when you do a gradient is you're doing the y-axis divided by the x-axis. So it's not just some arbitrary, strange, let's just do that. Let's look at this example. Okay, real life values. So we've got here a displacement time graph. Now if I want to calculate the gradient, it's going to be y, which is displacement, divided by time. So displacement is in meters, divided by time, meters per second. What's measured in meters per second? Velocity or speed. Okay, this is displacement time, so technically it's velocity. If it was distance time, it would be speed. Velocity is a vector quantity, so it has direction. You can get positive or negative velocity, whereas you can't. You can only get positive speed. Anyway, so if we wanted to calculate the velocity at t equals 1, we get t equals 1, we go up to it, we get our gradient, our tangent, which is just touching the line, and then we find two sensible points. Well, this is a very sensible point, 1, 3, and this is another one that the line goes through, 0, 1. So the change in y is going to be 2, going from 1 to 3, and the change in x is 1, going from 0 to 1. So the gradient would be 2. So the gradient at this point is 2 meters per second. So we can use this to find out how fast something's travelling at any point. If we wanted the gradient at t equals 3, again, we draw our tangent at t equals 3, and we just choose two sensible points. Change in x is 1, change in y is going down, so it's minus 2. So the speed at this point is minus 2 meters per second, which is correct because it shows our displacement. We're going away from something and then we're going back towards it, and we end up exactly where we started. So this sort of curve would be perfect for someone throwing a ball in the air. The ball's going up, it's getting further and further away, slowing down, stopping, and then coming back down. Okay, right, thank you and bye.